Last but not least, we have Professor David Balmforth with us today. Professor David Balmforth is currently visiting professor at Imperial College London, where he specializes in climate change adaptation, urban flood risk management, and urban pollution control. Without further ado, let us welcome him to share about the retrofitting of flood resilience measures in existing buildings. Professor, please.
Well, thank you. It's great to be here. A great privilege to be back in Singapore. I've been coming to Singapore for over 10 years on various advisory panels and to give lectures, and I'm always well treated. It's an exciting place to be. And the greatest thing about being an advisor in Singapore is they actually take some notice of your advice and go away and do something, usually fairly quickly. So it's great to be back again. And great to be back with my distinguished colleagues as well. I'm not great with technology, I should just tell you, so we'll see how we go. I'm going to talk about a completely different area now, which is looking at the places that we live and work, and actually looking at the consequences of flooding when floods occur. I just wanted to start with the 2021 floods in London. Now, you may ask the question, given the fact that we've got a huge barrier on the Thames and a load of flood defence walls, why have we got flooding? Why have we had 3 severe flooding events in 2021? People evacuated from their homes, multiple roads and underground stations closed. And it's because, to some extent, we've been looking the wrong way. And the thing you have to remember is not only do we get flooding from the sea, we also get flooding inland from rivers and drainage systems, and often these two things occur together. In many, many cities, there's a strong correlation between storm surge at the coast and the back up through the estuaries and overloading and flooding from our rivers and drainage systems because it rains heavily at the same time. This was a 100-year event. And if we just translate that and upscale that for UK, this is some IPCC projections and what it means for flooding in the UK. So at the moment, for all flooding events, we've got probably about 2.8 million properties at risk of flooding. Those are the residential properties, and a further 1.1 million business premises. Now, impacts of flooding can have a lifetime effect on individual people and where they live, and it can put businesses out of business. So it's really, really important, especially for more severe events. So the next 2 rows are about residential in properties that are at risk from severe flooding, and those non-residential industrial properties that are also at risk from severe flooding. And then we've added on some railway stations, lengths of roads, schools, the hospitals. And I just want you to look at the figures on the right-hand side to give you an idea of the scale of the challenge that we face with climate change. Some of the increases, the percentage increases there of flood risk and flood damage are actually quite frightening. And we have to find a way of dealing with this. Now, we've seen some examples of how we might tackle this risk on the coastal side. And I want to talk about my role in this panel, which is talking about inland flooding, which will be occurring potentially at the same time, and we also have to deal with. And many of you listening today and here in the audience in this building will have some experience of flood risk management, I'm sure, and you'll be familiar with the concept of the source, pathway, receptor approach to managing flood risk. I've just put an example of that up on the picture here in relation to a drainage system, but you could draw exactly the same picture for rivers, exactly the same picture for coastal defences. But it's really this little bit on the left-hand side, which I hope will work if I press the button. It's that little bit that I want to talk about today. The resilience of the receptor, the resilience of our properties, the places we live and work in, to flooding. Now, we know that we can make these buildings and premises more resilient to floods, that we can attempt to keep floods out and prevent damage so we can continue to live and work in them when floods occur. We have equipment and products available in the marketplace to provide barriers and flood doors, to provide pumping stations to deal with basement flooding, and also we can raise thresholds generally both on new properties and existing infrastructure and properties to deal with this issue. So we ought to think that we have a great opportunity here to manage flood risk in a different way by making our properties more resilient to flooding. So one of my questions is then, why when we get a flood like this, and this is the front room of a residential property in the London area, why do we just simply put back after the flood exactly what was there before? Because these properties are very susceptible to flooding. They're built from bricks, timber, plasterwork. All of that requires ripping out as it gets damaged during floods and replaced. Now, I met the family who lived in this house. They were just about to go away on holiday. The bags were packed in the hall. The car was outside. And just before they went away on holiday, the house was flooded. All their belongings were wrecked. All the suitcases were going to go away on holiday with, and the car was written off. So this is a big impact. We're talking here about people, their lives. We're talking about businesses, business continuity. And it just seemed to me to be crazy that we just reinstated this building exactly the same as it was before. Why is that? So I started to look into this, and I did a program for the BBC television on this topic. And in doing that, one of the places I went to was a property in South London, occupied by a lady called Mary. Now, when I was asked to do this, I imagined Mary was an elderly, frail lady who'd lived in a house and suffered from flooding. She actually turned out to be an ex-policewoman, in middle-aged, and actually she looked like an ex-policewoman, and largely she behaved like an ex-policewoman, or how you might imagine a person like that might behave. Now, her house had been flooded twice. So she decided she was fed up with this, so she would invest some of her savings, a lot of her savings, on putting in flood resilience measures. I visited her after the third time that her house had been flooded. And you can see the damage here. You can see things that have been ripped out. You can see it being dried out. And when she described her experience with me, this rather tough lady was in tears. She cried while she talked to me about her experience of being flooded. She had spent a lot of her savings to no effect. And I began to realize that the way we were approaching flood risk management, particularly on the resilience side, was not the way that we should be doing it. We weren't dealing with property flood resilience properly. When I started to look into this, guess what? I found loads more examples of bad practice. So if we look at this top left picture here. So here somebody has installed a flood gate on an industrial premises, but left the hole in the wall open. So the water knows it's not supposed to go down that hole in the wall when it floods, I suppose. That's the thinking somehow, okay? Then in the right-hand picture here, we've got a flood barrier fitted to a bay window in a domestic house. Unfortunately, it's fitted on the wrong side of the wall. It's been fitted on the inside, not on the outside. Then we've got the bottom left. Well, it looks all right a bit, but if you look very closely at those runners that the floodgate's supposed to drop into, you'll find actually that they're not screwed properly against the wall, so that's not going to work very well because it's going to leak. And then, interestingly, the one on the bottom right, quite a nice installation, very solid runners in there, fitted properly, big floodgate to drop in place. Unfortunately, by the time you half fill that space, if the water level gets up to that level, the wall's going to start to cave in because there's just too much hydraulic pressure on it. So, and I could actually spend a good half hour with lots more examples of bad practice. Also, when we're flooding, property owners go to their insurance companies pay out, the property gets reinstated, but it gets reinstated like for like. Insurers would not pay for betterment. Now, this seems crazy, doesn't it? Because the next time it floods, presumably they're going to have to pay out again. But of course, they allow for that because the one thing you find with insurance companies is they're not keen on losing money. So they will just bump the premiums up. And what happens when we bump premiums up? A lot of people don't renew their insurance. So more people were suffering even more from flooding. Also, because flood resilience of property and making property flood resilient didn't have a good record, government weren't interested in investing in it. They didn't want to put their money into something that wasn't it wasn't going to work. It had a bad reputation. And I was told that by our Minister of the Environment at the time, who told me in no uncertain terms during a flooding event, and he was under lots of pressure actually under this flooding event, but that said, please don't talk to me about property flood resilience, I think was his reaction. So I didn't. I went and did something else. I went actually and talked to some of my colleagues in the sector. I said, come on, guys, please, when I use the term guys, I'm not being gender specific. I'll just be clear on that, okay? All of you. We got together, we had a bit of a huddle, we had a meeting. It's always good to have meetings, isn't it? It's an excuse for doing something positive, but we had to have a meeting, and we had the meeting, and we got government agencies, insurers, surveyors, contractors, product suppliers, and even some property owners and just ordinary people from the street sitting around the table. What are we going to do about this? And we decided we had to establish what good practice looked like, because that was the only way we would then have a means of tackling bad practice. You can't tackle bad practice until you know what good practice looks like. What does good look like? That was our, we had a project. It was paid for by the government, a research and development project. But actually, interestingly, the biggest financial contributor to this was the insurance sector. We got one of the major insurance companies to just to underwrite this. They said, get as much money as you can from government and we paid the rest. So they did. Oh, I can see a big 10-minute signs come up at the back there. Just making sure you're giving me a right amount of time. Okay. Well, the first 3 meetings we had, we spent talking about what we meant by resilience in the first place. But this was quite important because there's a lot of misconceptions, because resilience is not just about keeping the water out. It's also recognizing that water will get in, and could we perhaps use building materials and finishes and fittings that don't get destroyed when they get wet? They can actually recover. Because what you don't want is, if you have damage to property, you don't want it to take months to repair, because we need businesses to keep running and we need people to get back in their homes. So we developed a code of practice. It took a lot of work, 18 months solid work on this. These are the different elements. I just want to quickly run through what they look like. First of all, really important to find out where the floodwater comes from. It's not always obvious. So that was the first step. Where does the floodwater come from? Source, pathway, receptor, get into the property. Second step, have a really good look at the property. How does the water get into the property? Does it come through the doors? Does it come through the windows? Does it come through the air bricks? Does it come through the drainage system? Does it come through that hole around the electricity pipe? Or just some random, or does it actually come through the brickwork because it's not been pointed properly? Or how does it get in? And that's really important, because you've got to start by understanding how resilient the property is to start with. Then you've got the opportunity to look at how do you then tackle it. And I'll show some examples of this in a moment. Where are you going to put the measures? Because you have to have a whole building approach to deal with this. So floodgates, flood doors, we know these work. They've got to be fitted properly, but are we going to use these? What you have to realize is that water will get past these devices. In almost always, not in every case, but almost always, some water will find its way one way or another into the property, and it's great if that doesn't build up. You only need about 300 millimeters of flood water in a property to cause substantial damage. So a sump pump is really good at managing that. And then look at waterproof finishes, waterproof linings on walls, waterproof fittings, waterproof, particularly kitchens, water resilient kitchens. Kitchens are really expensive to replace, but use water resilient fittings on there. And also in industrial commercial premises, this is an example of the Environment Agency's properties in Carlisle, which gets flooded from time to time. Glass panels, really easy to clean down afterwards, very durable. Carpets, low-cost carpet tiles are the best way, because you just pick them up and throw them away and put new carpet tiles down, because you do that periodically anyway. Lightweight furniture, you can move out of the way with the flood warning. Don't plaster the walls, you paint them. Membrane to reduce water coming into the building, and the electricity up at a nice high level so that doesn't get damaged. They just keep going. They can have a flood, they shuffle around for a day or so, and then they're back in business by the end of the week. A lot of work done on the drainage system in London, particularly basement properties, retrofitted pumps, which basically isolate the drainage from the rest of the drainage system, and then over pump it back into the sewers. And this stops levels backing up and flooding the properties. So all your basements, really look at carefully. You can isolate them from your drainage system and over pump them back. And the last point about options of design, remember, people have to occupy these buildings. Understand the people who are going to occupy it, because they have to live with the measures that you're going to install. Actually, these people really, they're very unhappy here when they've been flooded, but they're really chuffed when we finished doing the property resilience. Delivering, get a good contractor, somebody who's experienced. Clearing out and drying out the building is really important. It needs to be done sensitively. Don't just throw everything away, because some of those damaged items might be recoverable. Use competent contractors. Here's one for you, isn't it? Follow manufacturers' instructions. You know that little bit of thing that comes out of your appliances that you never read and throw in the bin? Well, please don't do that if you're putting in property flood resilience. Find out. Check the installation afterwards. Make sure it's been done properly. Work with the homeowner, a property owner, the business, demonstrate the installation, make sure they know how to use it, where they're going to store it. And there needs to be an operational maintenance manual. Make sure that that's done regularly so everything works when you really need it. Practice the installation. A quick summary on how successful this has been. 23,000 properties fitted since 2009 with government support. Most insurers now accommodate Build Back Better. Growing number of properties in flood risk area to retrofitted through private investment, and the code of the practice freely available. I've included the website so you can download it yourself. Always nice to get something for free. And then there's some summary information available for those who don't want to flog through the whole guidance. Just to finish with some examples of success. So on the left-hand side here is a basement property in London, very fashionable area, expensive basement property, protected by floodgates, but behind the floodgates are two sump pumps. They pick up anything that gets through the floodgates, the flood barriers. The one on the right, big reliance here on flood resilient fittings. So very nice modern kitchen, entirely flood resilient. You can see it flooded in the top picture there. It takes about, after the flood subsides, takes about an hour to clean it down, hour to 2 hours to clean it all out. Very all done, nothing, no nasty stuff left behind, easy to disinfect. And this is a bookshop in a small village in the Pennine area, north of England, a bookshop, a hardware place. This has flood resilient floors, lightweight finishes, flood resilient walls. It does flood. Flood water gets into this premises, but within a day or two, they've got it cleaned out, back in business again. Business continuity, really, really important. We are starting to quantify the reduction in damage. It's starting to come down. So the left-hand slides are, the top left is what the damages are without resilience measures. And you can see how that damage rises very, very quickly at low depths and then levels off. And if you look carefully, you can see that the resilience measures on the right are addressing the early part of that, but will only address it up to a certain flood depth. Once you get past about 600-700 millimeters, 800 millimeters flood depth, then defenses get overtopped, water gets inside, and you start to climb back. And this is why the recovery measures are so important. I just wanted to finish with the final picture, because actually what is behind property flood resilience is a fundamentally different approach to managing flood risk. Because traditionally, all our approaches to managing flood risk have been about reducing the occurrence of flooding. Flood defences and increased drainage capacity, managing rivers is all about reducing the probability part of flood risk. What we're looking at here is reducing the consequences of flood risk. And that still provides the opportunity, either completely or in concert with probability measures as well, in just getting down to the right risk level, enabling businesses to stay in business, enabling people to live comfortably in their homes, and also to enable us to have affordable insurance. So my conclusions are the code of practice establishing what good looks like has given confidence to stakeholders in the public. It's allowed government to give grants for retrofitting resilience measures. Insurers have agreed to Build Back Better. So if flood insurance is now affordable for properties with resilience measures, we're getting training schemes in place. They're in place now to make sure that contractors and design engineers know how to deal with these new methods, can get installation done properly. We've still got work to do on introducing a certification scheme of quantifying the benefits with hard evidence. But we've got a long way down the road from the situation we're in when Mary decided to spend some of her own money on resilience measures. Now we know how to do it well. We do it well. And this gives another big element in the toolbox of managing flood risk. Thank you very much.